potassium permanganate. Potassium permanganate is prepared by fusion of manganese dioxide with alkyl metal hydroxide and oxidizing agent like potassium nitrate, or it can be any other oxidizing agent. Like here, we have used is oxygen. Maybe we can say bubbling of air. So manganese dioxide with potassium hydroxide and oxygen bubbling will get potassium magnate ion. Further, this potassium magnate disproportionate in acid or neutral solutions. So we get permanganate. This is a permanganate having only a single negative charge, and we are getting manganese dioxide and water. Now, it will be interesting for you to see that this reaction from this magnate to permanganate is not spontaneous. Let's have a look at it. Here you see permanganate to magnate is spontaneous, but magnate to permanganate is not spontaneous. We have to take a reverse of it. We are converting basically magnate into permanganate, which is non-spontaneous. But the next reaction, conversion of permanganate to manganese dioxide, is a spontaneous reaction under acidic conditions. So what happens here is this reaction, which is spontaneous, and here we are taking a reverse permanganate to magnate. That's what happens. This is a 0.56 delta G for this reverse reaction, permanganate to magnate. Next is, what we see here is, then magnate, this permanganate further disproportionate to manganese dioxide. It got, we should say, reduce. This is spontaneous. We see here 1.69 NFE. E is tendon electropotential. Minus 5.07 F is for permanganate to manganese dioxide. So if we sum it up, here we are having 3 moles of magnate, out of it 2 moles we get permanganate, 1 mole of manganese dioxide. So this basically magnate reaction, so this reaction only makes the reaction spontaneous, because if we sum it up, this whole thing, we will get 3 into 0.56, meaning because 3 moles of magnate goes into permanganate plus 1 mole of permanganate goes into manganese dioxide, that is minus 0.507 F. That's how we're getting the whole term negative. So delta G is negative, means reaction is spontaneous. So this is basically an example of coupling reaction where reduction of permanganate to manganese dioxide drives the whole reaction. Manganese 2 positive is oxidized by stronger oxidizing agent like peroxodisulfate to permanganate. Here let's see an example. This is peroxodisulfate, and manganese got oxidized to permanganate, 7 plus oxidation state, and peroxodisulfate got, you see here, reduced. Let's see now the oxidizing characteristics of potassium permanganate. First, what happens in acidic media? Permanganate takes 5 electrons, or it acts as an oxidizing agent. It takes out the 5 electrons from a species that's going to be oxidized and reduce itself to manganese 2 positive. So it means 1 mole of permanganate takes up 5 moles of electrons, and this reaction is spontaneous. First, we see oxidation of iodine, iodide to iodine. When we put in acidic conditions, because iodide to iodine, what happens? 2 moles of iodide makes 1 mole of iodine, and it liberates 2 moles of electrons. Simple terms, we can see 2 moles of potassium permanganate can liberate 5 moles of iodine. Or 1 mole of potassium permanganate will liberate 2.5 moles of iodine, because every mole of iodide liberates 1 mole of electrons. Next, iodide goes to iodine. Next reaction is ferrous to ferric oxidation. Here we know every mole of potassium permanganate oxidizes 5 moles of any other species that is oxidized by only 1 oxidation number. Or we can say, like here, iron oxidation number changes only by 1, because ferrous to ferric, it means it loses only 1 electron, and potassium permanganate requires 5 electrons to reduce itself from 7 positive to 2 positive. So it oxidizes, every mole of potassium permanganate oxidizes 5 mole of ferrous ions, and ferric ion is smaller in size compared to ferrous. Next, oxidation of oxalate. Oxalate, each mole of oxalate loses 2 moles of electron. So roughly, what happens here? 2 moles of potassium permanganate can oxidizes 5 moles of oxalate, which in turn gives us 10 moles of carbon dioxide. That's what happens. Next reaction, nitrite to nitrate. Oxidation number changes from nitrate from, what happens, +3 to +5. So it means there is a transaction of 2 moles of electron. So every mole of potassium permanganate will oxidize 2.5 moles of nitrite, or 2 moles of potassium permanganate will oxidizes 5 mole of nitrite to nitrate. Next, sulfurous acid or sulfite is oxidized to sulfate by potassium permanganate under acidic conditions. Sulfite oxidation number changes from, here, +4 to +6. In such a case, same condition applies like nitrite. 1 mole of potassium permanganate will oxidizes 2.5 moles of sulfite. Next is sulfide, oxidation to sulfur. Again, this transaction happens. Sulfide loses 2 mole of electrons, so every mole of potassium permanganate will oxidizes 2.5 moles of sulfur. or 2 moles of potassium permanganate will reduce 5 mole of sulfur, oxidize 5 mole of sulfur. Sulfide got oxidized to sulfur. Now, next is potassium permanganate as the oxidizing agent in basic or neutral media. Oxidation of iodine was same, but here it is different. It got oxidized to iodate rather than iodine. And iodine oxidation number changes from -1 to +5, so 6 moles of electronic transaction. What happened, and manganese got reduces to +4 manganese dioxide. So in other words, you can see we need a 2 mole of permanganate to oxidize 1 mole of iodide. The transaction is reversed here. Iodine changes or oxidizes to iodic, and we get a iodate ion. Next is thiosulfate to sulfate. What happens here is oxidation number of permanganate changes to manganese dioxide. We change only in +3 or 3 electrons it will accept, while for thiosulfate it changes from +2 to +6, 4 electron transactions. In that case, what happens? Here it is 3, here it is 4, so we have to multiply it. So every 8 moles of potassium permanganate will oxidize 3 mole of thiosulfate. Oxidation number of thiosulfate on average is +2. Now next is manganese salt is oxidized to manganese dioxide, or minus Mn2 positive goes to Mn4 positive in the presence of zinc sulfate catalyzing this reaction. Now what happens here? Oxidation number of permanganate changes from +7 to +4, means 3 electron change happens, and dioxide 2 to 4. So we can say every mole of permanganate, which is 3, here it's only 2, can oxidize 1.5 of moles of Mn2 positive, or 2 moles of permanganate will oxidize 3 moles of Mn2 positive.